Hello, this is Natalie Moon. I am going to be talking with you today about thinking. We're going to look at conversions, ratio tables, some multiplication, division, some decimals. I cannot wait to be on this journey with you. I wanted to show you a picture of me so that you would know who you were talking to or listening to, I guess, perhaps. Hopefully you'll talk to me along the way also. This is me with Titan. He's my dog, my pride and joy. I've pretty much been spending all of my time with Titan and hanging out this summer working in my house. And I'm happy to be back thinking about math with all of you. So, the schedule today. You'll notice that I'm going to talk about 3 different topics, and the times that I'm going to talk about those are listed on the screen. So, you'll be able to kind of fast forward to those spots if you don't want to watch the whole thing. I totally understand. I listened to a podcast this morning that talked about thinking about and recognizing who has influenced you. And so I took a second to write down some of the people that have influenced me. My very first math professor, Dr. Cheryl Gregerson Malm, I will never forget sitting in her classes and her telling me, I don't know what you should do. You'll have to figure it out. Try something. She never would tell me how to do something, and I have never forgotten that. The second person I thought of was Jennifer Reniger, who might even not even watch this video, but has been a true influencer in my life. Just back in Springfield when I was working there, she believed in me and pushed me and gave me so many opportunities. And that's how I started really presenting to teachers in math. And what an opportunity. Math Academy, enough said. If you were a part of Missouri Math Academy back in 2007, 8, and 9, Dr. Larry Campbell, Joanne Barnett, Ann McCoy, I can't even begin to name everyone that made an influence in my life over that and throughout those years, my favorite times. The MSU Math Department, oh my gosh, just the education department and everybody there. I can't say all of their names because I'll probably forget one, but the way they've pushed me and pushed my thinking and given me opportunities, that started when the master's cohort started, when I got my EMS, the elementary math specialist degree in Missouri. Joanne Barnett, cannot say enough about that awesome lady. The way that she teaches math to students and teachers is amazing. And then, of course, all the people that I work with daily, the fellow math coaches, my best friends, Tracy Roussel alongside me in Ozark, Amanda Schweisguth, totally pushes me as a friend and a fellow math coach. There are so many people that have done that. Also, another thing that has made me who I am today is math recovery. Without Dr. Karen Scott and Ozark allowing me to be trained in this program and all that comes with it, I wouldn't be who I am. And Tracy Roussel being alongside me because she was trained first and teaching me everything she knows. We have learned so much about children's early number sense. And I'm just displaying one book that Math Recovery has written. But you need to know that everything I have learned from Math Recovery, Math Advantage, has changed the way that I know we should be teaching math to young children. Some of this presentation came about because I've been super interested about a lady named Pam Harris. And Pam Harris came on the scene for me a couple years ago, maybe even a few years ago. I lose so much track of time. And you'll see her information on the screen. By no means is this presentation only Pam, but a lot of what I'm presenting to you came straight from me learning from her. So I've been in a proportional reasoning class online with her. I have been doing Math Strat Chat for over a year. It's the best thing out there. You should try it. You can look at the hashtag Math Strat Chat. She has new podcasts that are challenging my thinking. In fact, if you watch her second podcast, it was from June. You'll have to go to her website, mathisfigureoutable.com, and then watch her podcast. And if you happen to watch the second one, you and I should get together because, boy, I'm having a lot of thinking going on from listening to them. So many things to help us be better teachers of students and helping them to be mathematicians. And so I just wanted to make sure I give credit where credit is due so that you know that not all of this is Natalie, but hopefully a lot of what I'm learning is helping me and will help you as well. So, first, we are going to do a little bit of noticing and wondering. So, on the screen, I've been walking a lot on the Frisco Highline Trail, but I don't want to really tell you any more about that. And I want you to just look at the screen. So, look at what's on the screen. What do you notice and what do you wonder? I want you to pause the video and think. You might need a pencil and a piece of paper today to keep track of some of your thinking because you're going to do math. This isn't just going to be something where you'll sit. Okay, so pause, think. When you're done thinking, come back and I will continue. Okay, so what did you notice and wonder? Well, I noticed and wondered that I must have been walking on a trail and I wasn't up to 2 miles yet, but I was past a mile. Okay. Oh, I noticed that 1 3/10 is 1/10 away from 1 4/10. So that's actually something I wanted you to notice, that I took pictures on the trail as I walked, and I took a picture of the 1 3/10, and then I took a picture of the 1 4/10, because obviously between those is 1/10 of a mile. I hope they notice that it's over a mile, under 2 miles. It's even under 1.5 miles. What did you notice and wonder? You might be wondering, what is she going to do with this? Okay, to start today, I was walking the Frisco Highline Trail, and I've been walking a lot lately and doing this, but the other day I got to this trail, and I've always wondered if my phone, my health app on my phone is mapping my steps correctly. And so I've been counting my steps as I've walked to try to figure out how many steps I walk in a mile, or how many, just to see if it's right with my phone. I know, I'm weird. I'm always thinking about math. So I don't have a Fitbit or anything. It just has never occurred to me to buy one. But the other day, I went to the trail and I found these signs that said how far I've walked. So I was like, oh my goodness, I can figure out how many steps I walk every 10th of a mile. And so I did. I walked between the 1/10 markers of several different ones to try to get an average of how many steps I take every 1/10 of a mile. So I found out that I take about, but we'll use 225. I take about 225 steps based on how fast I was walking pretty consistently to get 1/10 of a mile. So this is a problem. I'm going to take you through a series of different distances, and I want you to use the relationships between the numbers to try to figure out how many steps I take in different distances. But I want you to do it all mentally. That doesn't mean you can't get out a piece of paper and write some things down to try to figure things out, but I want you to use the relationships in the table. And, you know, in middle school, I called this a ratio table, but I don't see why we shouldn't bring it down to the earlier upper elementary grades. So I'm just keeping track. It's like an in and out table, fourth grade teachers. It's patterns. So here we go. Distance, 1/10 of a mile is 225 steps. So my question for you would be, what if I walked a whole mile? Think about that for a minute. So you figure out, what would you do to figure out how many steps I walked in 1 mile? Now, fifth grade teachers, I hope most of your students would say, well, we know there are 10 tenths in a mile. So 225 times 10, well, you just add a 0. Not, if you know me, I do not like saying add a 0, but you're right. We would multiply by 10, and 225 times 10 is 2,250. Okay, let's try another one. Okay, so now I want you to try to figure out 2/10 of a mile, but I want you to use the table to help you do that. So, what are some ways you could efficiently or creatively figure out the number of steps in 2/10 of a mile? Pause the video and then restart when you want to know more. If you know me well, you know I'd rather be sitting in front of you. Actually, I wouldn't be sitting, I would be standing and running around. But what did you do? How did you come up with 2/10 of a mile? I bet some of you, maybe most of you, came up with 450 steps because you doubled 1/10 of a mile to make 2/10 of a mile. That's what my mind does automatically. I'm hoping most students would do that. That's the purpose of this kind of a table so that they can find patterns within the table. Okay. Now, I hope there's some of you that did something totally wild and crazy, like maybe taking 2,250 divided by 5, because you know there are 5 2/10 in a mile. But that might be for the crazy people. Anyway, let's do another. Some of you might be wondering, so I'm supposed to do this in my classroom in one day? Well, probably not. I would imagine, unless it fit well within your lesson plan and you were teaching something specifically that went with this, then you wouldn't probably use it all in one day. You could start a problem string similar to this, and you could add a distance each day. You're wanting to build kids' flexibility, their efficiency, their creativity, their number sense. You're wanting to build their numeracy skills. You're wanting them to be mathematicians and to find connections and build relationships. That would be one of the reasons to do something like this. So now I want you to figure out 4/10 of a mile. Take a second. I'm going to come right back. Pause if you need to. Okay, I know a lot of you probably saw the doubling, but not all kids are going to see that right away, which is why we have to give opportunities in our classroom for kids to talk, for other kids to listen to their peers, for us to listen to the students. Doubling is huge, and many kids will grab hold of it, but they have to be given the opportunity to find it and see it. Otherwise, they're never going to know to use it. So 2/10 of a mile is 450. So double that is 900, 4/10 of a mile. Okay, some of you might think this is getting a bit old. However, remember, I'm trying to take you through why a ratio table or a pattern table is so visual for students. And this next one is one of my favorites because students struggle with some of the things about this, but I don't want to give it away. So, anyway, what if you were to figure out half of a mile or 5/10 of a mile? Or what if some kids didn't know that 5/10 of a mile was half of a mile, like I just said? So, I don't think I would pose it like that. But what if I asked you to figure out 5/10 of a mile? Pause the video, then come back. I love this one. I have been in so many fourth grade classrooms when students start multiplicative thinking or multiplicative comparison, and then they can't figure out how to do that because they're stuck in addition land. However, with this ratio table, how many of you added the 1/10 of a mile and the 4/10 of a mile to make your half a mile? And how many of you just divided 2,250 by 2? There are so many different possibilities in a table like this because then students can see, oh, I should have just divided by 2. Or, oh, if I know 4/10, then I can figure out and add one more tenth. It just depends on how a student's brain is working, but setting things up in a table help to focus their strategies so that they can figure out how they might do something when they don't have the table in front of them. So in this situation, of course, dividing by 2 would be more efficient, but adding certainly works. in an effort to make the video go a little bit faster, because I know it's getting kind of long, I would then go to 9/10ths of a mile. Then I might go to 1.5 miles, 1 5/10ths of a mile, 1.5 miles, say you, if they knew that that 5/10ths was a half. Why don't you try both of those, pause, and then come back and we will end this part of the session. I absolutely love this one. This is my favorite one when working with whole numbers. We've done a lot in our classrooms in third grade to help kids with multiplying by 9. No, not the nines trick. I don't like that trick. But anyway, look at this chart. How many of you added 4/10ths and 5/10ths of a mile and got your 2025 steps? I bet some of you did, because that's totally the purpose of a ratio table. However, the focus strategy that I'm going to work on in my classroom most often is subtracting from 1 mile. Who knew that 9/10ths of a mile was only one away, 1/10 away from a full mile? And so if you know how to subtract 225 mentally from 2,250, then that's one step. It's that simple. And a child that is multiplying by 9/10ths is probably not going to automatically know 4/10ths right away. They might know half, 5/10ths, but I don't think they'll know 4/10ths. But they would know to subtract from the whole or the 1 mile. So try that when you are multiplying anything to do with a 9. 9/10ths is close to 1 whole. And then 1.5 miles, the next one is so fun. I mean, look at your chart. You know a mile already, and you know a half a mile. It's that simple. You have the whole 2,250, and I bet a lot of you did this. And then you added the half a mile, 1,125. You could go so much further with this ratio table. I could go to 2 miles. I could go to 3 miles. I could go to 2.5 miles. The purpose would be to continue forming relationships between numbers, helping kids develop their ability to be a mathematician, because all kids are. Okay, so try this problem. Now, the goal here would be for you not to use the ratio table, because we just spent so much time developing different strategies. But what could you do to figure out how many steps I would take in 1 7/10ths of a mile? Remember that 225 steps was 1/10 of a mile. So what could you do? What strategies could you use to get to 1 7/10ths without just multiplying 1 7/10ths by 225? How could you be creative? You can pause, think about it, and then look at the following slides to see how I solved it. I hope you enjoyed learning about a problem string. In Pam Harris's book, the one that I showed you at the beginning, she would say a problem string is a purposefully designed sequence of problems that are related. The goal is to help students find relationships. And then some of the time you are trying to nudge them, I like how she says that, towards an efficient strategy. For instance, the nines, or finding half of the mile. And you can do this with whole numbers as well. I just wanted to make sure I was touching on what fifth grade teachers might use, and even older students. I hope you enjoyed learning about problem strings. Okay, now we are going to look at multiplication. And I would say this is third grade and up. I'm hoping, at least in our buildings, my own school district, we are using lots of visuals. I am going to share with you some number strings within ratio tables and visuals to help students focus on different strategies. My very own teachers that work with me are just rocking it out of the house with their third graders with all the strategies. And so we want to try to continue that into the older grades so that they continue seeing all the relationships between numbers. So here is the first strategy. The first strategy is going to be an image in a second. And there are so many different ways you can present this strategy and represent it. But when you see the screen in a second, how many dots do you see that are actually there? So there's the screen. How many dots do you see? I see 12. And a second grader I've been working with said, "Oh, there's 2 rows of 6. I see 2 rows of 6. There are 12 dots." So I might ask the student, "Well, then how many dots would 4 rows have?" Well, wait a minute. We already have 2 rows. So 4 rows would be double that. And the third graders we have worked with this year, one of the teachers that I can think of right now, her name is Savannah. Her kids just double, double, double all the time. Wherever they see doubling happening, in the numbers, they know they can double. So if you have 2 rows of 6, then 4 rows of 6 will have 24. Now, a lot of curriculums would just show you the algorithms or the equations, expressions that I have written below the dots. 2 rows of 6 is 12, so 4 rows of 6 is 24. But the visual gives kids something to attach it to. They can picture that now. And I can hear Tracy, I think this is the second time I've said her name today. I can hear her saying, give the kids more visuals, allow them to see it. So we know that 2 groups of 3 is 6. So double that, 4 groups of 3 would be 12, and 8 groups of 3 would be 24. Working on their 2s, their 4s, and their 8s could become easier for kids if they saw the doubling. But they've got to have this kind of number string or visuals to help them to be able to use that in the future. They're not going to be able to use it if they've never been given the opportunity to experience it. So the focus of using the representations will help the students build relationships between all the numbers. Okay, so this second strategy, in a second, you're going to see some images flash on the screen. And it's another video I've made that I've inserted into this video to help you see the second strategy come to life. But you need to be able to visualize things. So I found a quote. Joe Bowler has done a ton of research on the brain. And I can hear lots of people in my life saying, visualize, Natalie. Students need to visualize. When students visualize, it helps our brains to think of math visually. We need to give kids something to relate it to. If they have an image of it, they might be able to figure it out. So remember to use visualizations. Okay, this is one of my favorite routines. And a lot of what I've talked about today are ratio tables and using tables to organize your thinking. But I'm going to tell you that visuals, along with that, is huge. Kids have to have a picture in their mind so that they can figure out what to do with the numbers. But they have to see it. Some of them, they have to see it. I can hear Tracy Roussel, my fellow math coach, saying, Natalie, we have to do more visuals. We're not doing enough visuals. So here are some visuals that we use in a third grade classroom. There is so much more you can do with K2 also, not in the sense of multiplication, but here is an image. So I'm going to flash it. It's going to be kind of fast. I'll try not to go too fast. So watch the screen. Are you ready? How many did you see? Now, I've done this with actual kids, like real kids, third and fourth graders. How many did you guys see? I saw 70. I'm hoping a bunch of you are going, 70, I saw 70, Natalie. Well, how do you know it was 70? I saw 10 groups of 7. In K2, we do a ton of work with 10 frames. And so in third grade, if we can use those 10 frames to our advantage and put dots in them to represent multiplication. So a lot of kids see 70. In fact, I don't know any kids that don't see 70. Some kids say 10, and then they remember there were 10 groups of 7 and it's 70. I think I used the word mumbo jumbo more than once in today's session. But look at, you're using 10s to help with 9s. The blue equation on the right side of the screen, those two equations are so hard for kids to understand until they've had something to relate it to. So by using the visuals and modeling the notation, that blue part's called the notation, then that helps kids relate to what in the world we are doing and how to write it. Writing it is not near as important as listening to kids and their thinking. And as they explain it to you, then you can write the equation to model what it looks like mathematically. The third strategy is another video of me flashing some dots at you. So be ready. Here is the next strategy. I am going to show you a visual. Are you ready? Watch closely. Here we go. How many did you see? Again, I'm using those 10 frames to activate kids' thinking to something they already know. Oh, did you see 5 groups of 4? I saw 5 groups of 4 or 20. That's what kids are going to see. They're going to see 20 dots because it's 5 groups of 4. Okay, so there are 20 dots in 5 groups of 4. Did you see it? Okay, watch the next screen. How many? How many did you see? I didn't see 5 groups of 4. Did you see 8 groups of 4? Natalie, I saw 3 more groups of 4. You did. So if 3 groups of 4 is 12, how many are there all together? You're right. 20 and 12 makes 32. 8 groups of 4 is 32. Now, I have a student. I won't call her a name. She goes to one of my schools. And working with her all year, she was getting third grade. I'm not kidding. She was getting so good with her facts. She wasn't necessarily fast all the time, but I remember when I would ask her 8 times 5, and she would always freeze. And she would say, Mrs. Moon, hold on. 5 times 6 is 30. So 2 more 5s it's 40. She could use that grouping starting with her 5s. That was just the strategy that was her go-to. We have got to provide kids with a visual so that they can use what they know to help them get to what they don't know. And then at some point, they will know what they didn't know. Here is the modeling once again, modeling the blue equation so that kids can get a feel for what that notation is all about. So every time kids say how they figure something out, write it down so they can see what they are thinking. Hello, teachers. Okay, so now I'm going to move on to some problem strings using a ratio table again to keep track of our thinking, to look for relationships. And so this might be for third graders in second semester of the year and fourth graders and definitely fifth graders and so on. And you already saw me use some decimals today in a ratio table. So we are going to start with cartons of eggs. Now, if you have heard me talk about Pam Harris, um, her problem that I love the most is about packs of gum and sticks of gum. So you really should look that up. It's on her website. If it's still there, I used it with an eighth grader, and that really helped her to understand ratios and proportions. But I'm just talking about multiplication and looking for relationships for fourth graders and third graders as well, and anyone else. So, let's do cartons of eggs. So one carton of eggs has how many eggs? Well, 12. I know, 18, 30, and all these other numbers as well. But let's just talk about one carton with 12 eggs. So what if I had two cartons? Now, we've already done this today if you've watched some of the other parts of this presentation. So 2 cartons would be 24 eggs. It doubled. I hope kids are visualizing that as you've seen already in this part of the presentation. But what if I didn't want 2 cartons? What if I was going to feed a bunch of people eggs and I wanted 20 cartons? I'm not going to do what I did on the other presentation. I want you to just think along with me. Take a second. Oh my goodness. If I need 20 cartons, it's 10 times as many cartons as 2 cartons. Now, fourth grade teachers know that that multiplicative comparison is so hard for the kids. But in this way, I can see a relationship. 2 times 10 is 20. So 24 times 10 is 240. Not just add a zero, fourth grade teachers. Oh, I know. Everybody's over that, I think, in my district at least. They could be laughing at me. So 20 times 12. Oh my goodness, you just did 20 groups of 12 is 240 using the relationship you know about 2 cartons. So now what about 10 cartons? Now I could have done that right away. How would you do 10 cartons? Some of you might take 1 carton times 10. You see that relationship. But others of you might do half of 240 because half of 20 cartons is 10 cartons. So we have 120 eggs in 10 cartons. Look at the relationships we are finding just using a simple table. Okay, what about 5 cartons, teachers? How many would that be? Now, you might not be using this table all in one day. You could add different numbers in short number talks at the beginning of your lessons to get kids thinking, to continue building their multiplicative thinking skills. So I don't need 10 cartons anymore. I only need 5. Well, I could do 12 times 5, and I've seen kids skip count for days. But instead, what if they knew half of 10? Half of 10 is 5. So what's half of 120? And I think to a teacher at North Elementary in Ozark, she was loving doing some of this doubling and halving with her second graders. So they had been practicing, half of 32, half of 60, half of 54. Oh, those are doozies for second graders. But what about half of 120? Well, half of 12 is 6. So half of 120 might be 60. Look at all of the relationships. Kids are thinking about numbers. They're being problem solvers and mathematicians. What about half a carton? Oh, well, I pulled in a fraction, but if 1 carton is 12, then what's half a carton? 6. Okay, so what about 15 cartons of eggs? Now, kids get really excited when they can figure something out that might have been too hard if I would have just put 15 times 12 on a piece of paper for them. But what about using this chart? What do they already know that we can help them build a relationship with 15? So I see that 10 cartons is 120 and 5 cartons is 60. 15 cartons must be 180. Now, I have done number strings and such to help kids see that in other ways, but I really love that kids could do 10 groups of 12 and 5 groups of 12. And oddly enough, when I've done a number talk with kids before, because of what we do in third grade with the distributive property, many students will do 14 times 6, and they will do 10 times 6 and 4 times 6. I'm sure you have experienced that, but kids have to be given those opportunities to see that that works. In fact, I was at the dog park just a couple days ago, and this third grader, he's going to be in fourth grade, and I asked him, I think it was 17 times 6, and he looked at me and went, I can't do that. And he probably could have, but he needed something to help him relate what he already knew. And I feel like we are doing that, at least where I am at in third grade, but we have to continue building that and helping them to see those relationships in fourth grade and beyond. So 15 groups of 12 is 180. Okay, what about 50 cartons of eggs? Oh my goodness, 5 cartons of eggs is 60. So 10 times as many cartons would be 600 eggs. And other students might have done 5 groups of 10. So 125 times is 600. Just depends on the relationships they see. But I would bet the 5 would help them with 50, maybe more efficiently. And we are looking for kids to be flexible thinkers. So what about 100? 100 cartons of eggs. Now, we could have gone all the way back to 1 carton of eggs, right? Some kids will. Other kids would go, well, 10 cartons of eggs is 120. So 100 cartons of eggs is 1,200. It's 10 times as many. Now, the last one I'm going to share with you is one that I'm being challenged with. I'm not here yet, but hey, I might as well challenge other people to think, just as I have been challenged to think. So what if I told you the amount of eggs instead of the amount of cartons? Now, I'm being challenged here. I'm really thinking deeply about, I don't want to say the word, the other word, other than multiplication, the inverse, the opposite. So I don't want to say it. You guys will get it, I think. So 204 eggs. Gosh, I have no clue. I mean, 240 eggs is 20 cartons, so it's got to be less than 20 cartons. Oh, 15 cartons of eggs is only 180. Oh, so it's more than 15 cartons. Oh, well, 16 cartons would be 192. So I'm using relationships. I'm using something I already know instead of just trying to divide to figure it out. I'm using multiplication, using what I already know to figure it out so that I'm making sense of the numbers. So I'll leave you there with that. And that is all I've got for multiplication. There's tons more. We could get into division. I'm just not there yet in my own thinking. And I'm still trying to work through some of that. So I hope you enjoyed this part of the presentation today. Thank you. With all of my thinking about ratio tables, I started to think about conversions, and they are so hard for kids to decide if you need to multiply, divide, etc. And I hate when they just have a trick or a thing they have to try to remember. But I love the idea of them putting their information in tables to help them make sense of what they're doing. And so I tried this with fifth graders in March before the whole COVID thing happened, and it worked. A lot of kids made sense of using the ratio tables. Remember, this is just an introductory way to help kids be able to organize their thinking to make sense on their own. So we had a little lesson plan. You can download that. I will make this presentation available, which means you'll be able to click on those links when you go into the Google slideshow and download those lesson plans. One's in Word so that you can change it, and one's just a PDF. But the first thing I did was I put this chart in front of them that I made. And all the kids had one, and I said, what do you notice and what do you wonder? And this is a bar model diagram, which you probably can tell. And this was just a visual that helped them to see capacity, length, and weight visually, so that it wasn't just a chart that said 1 cup is 2 pints. It actually shows them that. So then I showed them a ratio table comparing feet to inches just to see what they would say. And this is a ratio table I made. I said that if 1 foot is 12 inches, then 2 feet must be 24. And the kids very readily thought, oh, that's just double. And then the half a foot, they knew that that was just half of 12. The 48 was double the 2 feet, or even 4 times the 1 foot. And then what was most fun was the kids trying to figure out 2.5, which this is why I love ratio tables. There's so many different things you can do to make it work for you, depending on how kids see the relationships in the numbers. And so the students immediately said, well, wait, if we know 2 feet is 24 inches and a half a foot is 6 inches, then 2.5 feet must be 30 inches. They added those numbers to get the number of inches in 2.5 feet. After we activated the students' thinking with the bar model diagram showing all the conversions, and then the ratio table explaining how that worked and letting them notice patterns, we gave them some problems where I provided the ratio tables with less and less scaffolding. So on the 1-star ones, I provide the ratio table with everything filled in. With 2 stars, I kind of gave them a head start, but didn't really tell them a whole lot about the problem. And then on the 3-star ones, I just gave them a blank table and let them go about those problems how they wanted to. So you take a second, pick one of the problems, see if using the ratio table helps you to organize your thinking so that you know how to figure the problem out and you're able to make sense of it. And then after you are done, you can restart the video and there will be 3 short video clips showing how I solved each one. Of course, there are many different ways to solve each of them, and you do not have to have a ratio table. We just found that it did help kids organize their thinking. Hello, teachers. This is Natalie. I put 3 problems up on the screen for you to look at. These are the same problems I put in front of the 5th graders, and every 5th grader went at them a little bit differently. Some students did start on the 1-star problems, and then you always have your overachievers who try to start on the harder ones. But for this problem, I watched 5th graders very easily. Once they saw this table, it just triggered in their brain that they could understand what they were supposed to do. So it wasn't about me doing a cheer about whether you multiply or divide. It was based on the kids knowing that if 1 pound is 16 ounces, then 40 pounds would be times that. I would do times 16. Now, a ratio table's purpose is to help students, in my opinion, build relationships between numbers. So if a child did not know how to do 40 times 16, which we all know you could do 16 times 4 and then multiply by 10, which would be totally fine. I could also use the ratio table to help me. I might figure out 10 pounds. And if I know that 1 times 10 is 10, then 16 times 10 is 160. So a ratio table's purpose is just to organize information to be able to see the relationships between the numbers. At that point, I could do times 4 to get to 40. Or I could figure out 20. I know that 10 pounds is 160. Well, 10 doubled to 20. 160 doubles to 320. Now, I could talk about how I know that. I'm not going to do that today. But now that I know 320 ounces is 20 pounds, I could very easily go back to 40 now. See my different colors? And double that to get 40 pounds. Lots of different ways that kids might choose to use a ratio table. I think most kids that I worked with that day knew that the 40 times 16, of course, was 640. So 640 ounces is in 40 pounds. Okay, this problem got 2 stars because the Mighty Mite problem isn't only one step necessarily, and I didn't fill out the ratio table. So I'm giving them a chart from scratch to see if it helps them. I read the problem and it says the Mighty Mites need 60 quarts of Gatorade. But then that's not all. How many 5-gallon containers will they need? So students are going to need to know that there's 4 quarts. Oh, I got to get my pen working. There's 4 quarts in 1 gallon. And this chart, this is just, I'm calling this a ratio table. That's what it's been called. A lot of middle school teachers use these when they get into their ratios and proportions. I think it's an excellent way to organize your conversions to make sense of what's happening with conversions. So 4 quarts in 1 gallon. So if I needed 5 gallons, I know that I would just need to multiply that times 5. And I'm trying to help you out with the markings I might put to help me track my thinking. So 5 gallons is 20 quarts, but that's not what I need. I need 60 quarts. So there's lots of different ways kids, some kids will stop right at this point and go, well, 20 times 3 is 60, so I just need 3 5-gallon containers. Other kids might need to write that down and go, I'm going to switch colors. They might need to actually put 60 on the chart and think, okay, so 20 times 3 is 60. So I would need 5 times 3, which is 15. So 15 gallons is what I'm working with here. Well, how many 5-gallon containers will they need? They will need 3 5-gallon containers. Every kid is going to go at this a little bit differently. The reason I use this ratio table is just to help me organize my thinking, to look at the relationships between the numbers. So on this problem, I used a lot of multiplication. Okay, I will admit to you now that I wish this was live because people could talk to me about how they figured it out, but I had to really kind of messily think about how I was going to keep track of my thinking. You realize that if I just start writing down all these things, nobody knows what I'm thinking. So by using a ratio table, I can kind of help others to see my thinking. So I'm going to start with ounces. Gallons aren't really going to help me with ounces because I don't know the conversion between gallons and ounces, but I do know the conversion between cups and ounces. So I'm going to start very simply with the fact that 1 cup is 8 ounces. And I know you're thinking, but Natalie, there's nothing. I know there's not, but I got to get to gallons somehow. So if 1 cup is 8 ounces, then 4 cups will be 32 ounces. Now, come on, everybody. You know, or you might know, teachers, students, that if 4 cups is 32 ounces, then 1 quart is 32 ounces. Because 4 cups are in a quart, okay? So 4 cups is a quart. I know that a quart is 32 ounces, but I still don't have gallons. So I need to now know what I know about quarts. Well, there are 4 quarts in a gallon. So now I used times 4 there. I'm going to do the same here. I don't want to know 1 quart. I want to know 4 quarts. So 4 quarts is, holy cow. Now, I know what 32 times 4 is because I've done it enough. I know that 30 times 4 is 120, and then 2 times 4 is 8. So 128 ounces is 4 quarts, which for all of you that know, 4 quarts is 1 gallon. We finally made it to what we were looking for. 128 ounces is 1 gallon. Now, look up here. Darn it. She needs to feed Rowyn 140 ounces, not 128. So I'm going to go to the next slide so that we can think about it and I don't have such a messy slide. We just found out that there are 1 gallon is 128 ounces. Well, I need 140 ounces. So I know that 12 ounces is remaining. I need 12 more ounces. She's going to have to go to the store and get more milk. Well, 12 ounces is how many cups? Well, 8 ounces is 1 cup. Didn't we already know that from our chart on the previous page? And 16 ounces is 2 cups. Wait a minute. 4 ounces is a half a cup. Who saw that coming? And so a cup and a half is 12 ounces. So Mrs. Gore needs to buy a cup and a half more milk so that she can feed her daughter. Now, hopefully she'll just go buy another gallon of milk. But she needs an extra cup and a half to make up that 12 ounces. Do you see the relationship? That's why ratio tables are so awesome. 8 ounces and 4 ounces makes your 12 ounces. So I need a cup and a half of milk. I hope you enjoyed today. Thank you so much for listening. You can email me, Facebook me, or tweet me if you have any questions. And the first person who's a classroom teacher that emails me and tells me 3 things you learned today will get a book of their choice. So a book that you've been wanting to read, that's a $30 value or less, I will be providing you because I want to support math educators in learning. And I have lots of ideas of things you might want, but I don't just want to offer one. I want to let you pick. So email me 3 things you learned today and how you might use them in your classroom. And I wish you the very best in this coming year, positive attitudes and love for all those kids you are going to be influencing. Please don't hesitate to email me, Facebook me, or tweet me. My email is on the screen here, and the lesson download link is a tiny URL, Natalie Summer MCTM. You will be able to get the presentation, and then on one of the slides, the slide listed, is the conversion link to get the download of the lesson plan and the problems. Have a wonderful day. Bye-bye.